Let's talk about the series combination of resistance. We have three resistors here, R1, R2 and R3. The values are 20 ohm, 30 ohm and 40 ohm, and they are all connected in series and across a battery here. This is a 10-volt battery. Okay, and here we assume this battery has no internal resistance. So this is the EMF, or this battery has no internal resistance. So there is no any potential drop across the battery itself. So what do we need to find out? What is the equivalent resistance or the net resistance? We also be finding the current in the circuit, the potential drop, the power supplied, and the power dissipated across each battery. Let's do this one. So here, as the batteries are connected in all the resistors, all the resistors are connected in series, the same current will be flowing through each resistor. And why is that? Because the current has only one path, and the path is through each resistor. So the same current, whatever flows in this 20 ohm, it must flow through 30 ohm, and it must flow through 40 ohm. So it has only one path. So the same current flows through each resistor. So the equivalent resistance is given by this equation here, R1 plus R2 plus R3. We already have talked about if the resistors are connected in series, then the combination is given by R1 plus R2 plus R3. So this is 20 ohm, 30 ohm and 40 ohm. So if you add them together, that gives you the 90 ohm. So finding the net resistance is very straightforward. Now let's find out how much current flows through the circuit. So as we have found out this net resistance, that means all these three resistors can be replaced by a single resistor whose value is 90 ohm. That's what I did. So if we have one resistor and one battery, how much current flows through this one? This is given by Ohm's law, or by V equals to IR, and I would be equal to V over R. So V over R, the V is 10 volt and R is 90 ohm. If you solve it, you'll get 0.11 ampere. So this current is passing through these resistors, and as they are all connected in series, the same current will be passing through each resistor. So through each resistor you will get the same amount of current, I1, I2, I3, I4, everything will be same. I think no I4, so just I1, I2 and I3, it will be equal to 0.1 ampere. So once we know, now we know the current and we know the potential. We know the current and we know the resistance. So look, we can find out the potential drop across this one just by using the Ohm's law. So V1, that's the V equals to IR is the Ohm's law. So the V1 would be equal to I1 times R1. The I1 is the current through this one and R1 is the resistance. How much current is through this resistance? We already have calculated is 0.11, and the resistance value is 20. So if we multiply them together, we'll get 2.2 volt. And the same way, we can find out V2. I2 times R2 will get 3.3 and we'll get 4.4. Now we have the larger the resistance, the more the potential drop is. Okay, so more the potential drop is, and it makes sense. In order to drive the same amount of current, you require a bigger potential difference across the larger resistance. Okay, so 4.4 volt is dropping across this one, double of this one. You see, this is 2.2 and this is 4.4. But if I add them together, all this together, 2.2, 3.3, and 4.4, we'll be getting 9.9 volt, which is 10 volt here. Okay. So the total potential drop must be equal to the supply voltage, which is the 10 volt. Now let's find out the power lost across each resistor. So first we're going to find out how much is power supplied. The power supplied is equal to what is the current in the circuit and what is the supplied voltage. So we already have found out the current in the circuit is 0.11 and the supplied voltage is 10. So the power is equal to I times V. This is the power supplied. I is equal to 0.11 and the supplied voltage is 10. So 1.1 watt is the power supplied. Now let's calculate if 1.1 watt is power supplied, how much is the power lost across each resistor, or how much power is delivered to each resistor. Let's do that. The power across any resistor is given by this formula, I squared over R. It's exactly the same formula here, P equals to I V, and we know that V is equal to IR. So if I plug in V equals to IR, it will be I squared R. So it's exactly the same formula. Okay. So now P equals to I squared over R. The current in the circuit is 0.11, or through R1 is 0.11 squared. R1 is 20. If you solve it, you'll get 0.242. The same way, we can calculate the power delivered to the R2 and power delivered to R3. And if I add them all this together, P1 plus P2 plus P3, what we get is 1.1 watt, which is the power supplied by the battery. So the one point I would like to make is the power supplied by the battery is exactly equal to the power dissipated by all the resistor. Okay, so it does not store any energy. All the power that is supplied is dissipated. Unlike capacitor, there is some storage or inductor, but in this case all the power that is delivered by the battery is dissipated in the form of heat energy or in the form of light energy. So now let's do exactly the same thing using this simulation. So here, let me open this one. I have exactly the same value here, 20 ohm, 30 ohm, and 40 ohm. And I've connected exactly the 10 volt now. So what we measured here is the current. Now let's measure the current in the circuit. So for that one, I need to break up at some point here. So here I'm going to measure the current now. Okay, so you see now, even it is a little bit tilted, that's fine. Okay, you see now the current in the circuit is 0.11. That's exactly we have calculated, 0.11. And this is the current into the circuit here. So now let's measure the voltage across 20 ohm. 2.22 volt. Now let's see what we had got. We had got 2.22 volt here too, and across this one is 3.3 and 4.4. So now let's check it. 2.2, and now let's measure across R2. R2 is 3.3 and across R3 is 4.4. Okay, and now if we measure across all the resistor, it has to be equal to 10 volt. So that's what it is. So using this simulation, you can in fact calculate all things, or you can double check your answer. So this simulation provides a wonderful tool for you to visualize how things work in reality. So I would say just play with this simulation. If you have any confusion, if you want to double check your answer, this platform provides a wonderful tool for you. Okay. So if you have any questions, let me write down your questions in the comment section below, and do not forget to like, share and subscribe the channel. Thank you.